Okay, so we're going to talk about the polynomial functions. So like I said earlier, linear functions, this is a grade 10 topic that we did. You did. I did with, my other grade 10 students before. It can be sloping up and sloping down. We'll discuss that later. And then this one is called a quadratic function. Okay, quadratic function, and it produces a parabola opening up or opening down. The general form would be ax squared plus bx plus c, right? So this is a degree 2. I'll put here degree is 2. I gotta go back up here and call it degree 1, right? What is a degree again? Yeah, what's the definition of a degree? What's that? The power, yeah. Highest exponent in a polynomial function, right? So this one here, the highest exponent is 2, so that's a degree 2. Okay. What do you call this one? This one is called cubic function. Cubic function. Okay. And what's the general form for cubic function? Equals to, because it's a cube, so it's going to be ax cubed plus bx squared plus cx plus d, right? And the a, the b, the c, and d are just numbers, right? Integers. Or not just integers, it could be any real number. What's the degree?
It's a 3.
Degree 3, because that's the highest exponent is 3. Now, what's this one? This is called a quartic function. Okay, so quartic. It sounds like a quarter, right? Right? When we say quarter, it means 4 parts, or quart means 4. What's the general form of that?
It's a
Y equals x to the 4
minus b
we'll go plus, okay, plus bx cubed, 3, it goes down, plus cx squared plus d times x plus e. Okay, we're trying to fill in the coefficients there, a, b, c, d, and then a constant e. Okay, and what's the degree here? Degree is 4. 4th degree. And then last one is called a quintic function. And okay, now we're gonna have fun writing it down. It's called, the degree is ax to the 5th plus bx to the 4th plus cx cubed plus dx squared plus that looks like an exponent ex plus f. Okay, and a, b, c, d, e are coefficients, and then the f is the constant. And what's the degree here? Degree is 5. The word degree is the highest exponent in a polynomial function. Okay, so that's that. Okay, so what we're supposed to do is we're supposed to kind of generalize, see what it should look like. So when somebody says a quadratic function, you already kind of have a picture. Oh, okay, it has to be like this, right? Okay, if I say it's gonna be a cubic function, it should give you kind of a mental picture of what a cubic function looks like. So here it goes. Let's take a look at number on page 16. Page 16. Did it have a page 16? Yeah, this is page 16. After, it says there, the next page basically, after inspecting the graphs on the other side of the page, let's see if we can, as a class, can see what's going on. Some kind of what do we notice? How does the sign of the leading coefficient affect the shape of the graph? How does the sign of the leading coefficient affect the shape of the graph? Now, first of all, what does this leading coefficient mean? What is a leading coefficient? Have you heard of the leading? Okay, that's the highest, and then the leading coefficient would be the, okay, if you take a look at this, which one's the leading coefficient? The A's, right? These are the leading coefficient, and it's the one that's multiplied with the highest degree. So the leading coefficients are the A values. You see A's, right? For all of them. The A values in our polynomial function. How does the sign of the leading coefficient affect the shape of the graph? Now let's take a look. The direction, yeah. Okay, let's take a look at this one. So, your fellow classmate says it gives the direction of the graph, right? Here, this is a positive leading coefficient. Where's the direction of the graph? It's going this way, right? It increases to the right. What about this one here? The leading coefficient is -1. And if it's -1, it goes down, decreasing. Okay, okay, good. Decreasing. This one here, the leading coefficient is a positive, so that means it opens up. This is a negative leading coefficient, it opens down. Okay. Letter E. This is a positive, so what happens here is that it kind of swirls this way. Okay. As you increase the x, it goes to the right, increases to the right. And then over here, because it's a negative, it decreases. Okay, it changes to the opposite direction. When you also think about it, what's that?
What are you saying at the end?
The end behavior, yeah, the end behavior would be the opposite. Do you notice that it kind of, okay, kind of word, I'll use the word flip. What does it flip mean? It kind of flips the other way. So if it's increasing this way, now it's gonna flip the other way, right? We'll talk more about that later on when we talk about the reflection and this one here. It's opening up, now it's flipped down. Okay, try flipping this in your mind. So it kind of looks like this, and then it flips, right? The quartic, if it's a positive, it's all gonna be up, and then this one, it flips it down, brings it down. Okay, so what does the leading coefficient, or how does it affect the shape of the graph? The shape of the graph. The lead coefficient the direction of the graph. Okay, it changes the direction where it's going. Okay, the direction of the graphs. So far so good?
The direction of F?
The direction of the graph. When we have the graph itself. Yeah, so if it's going this way, it brings it down. Okay. Ooh, that's kind of blurry. Let's focus that one. Okay, so far so good? Now let's take a look at letter B. What does the value of the constant term tell us about the graph? Okay, well, first of all, which one is a constant term? The last one. The one that doesn't have the x variable multiplied to it, right? So the constant term is the one that's not multiplied by x at all. Okay? So what does this value tell us about the graph? The y-intercept. Yeah. So the constant term tells us the y-intercept of the graph. Okay, that already tells us, hey, whatever this polynomial function is, we already know the y-intercept. We already know one characteristic of the graph. Okay, y constant term.
The intercepts where it crosses y?
Yeah, that's right. So i.e., let's type that. Let's type it. Let's write it down. Where the graph crosses the y-axis. Okay. So where does the graph crosses the y-axis? That's already kind of a given there. Okay. So far so good. So we know that the leading coefficient gives us a direction. We know that the constant terms gives us the y-intercept. Now let's keep going. What characteristics do the odd degree share? Odd degree. Okay, which one's the odd degree? Okay, the odd degree means has a degree 1, 3, 5, 7, Keep going. Okay, odd degree. What do they share? What do they share? Let's take a look. These are the odd degrees. The linear, the cubic, the quintic. Yeah. Okay, so this one you're talking about the end behavior. First quadrant, third quadrant to first quadrant, or quadrant 2 to quadrant 4. Is everybody okay with the word quadrants? And okay, quadrants 1, 2, 3, 4. Okay, so odd degrees, you could see, okay, that if a lead coefficient, oh, you can't see that, sorry. If a lead coefficient is positive, the end behavior is quadrant 3 to quadrant 1. Okay. And then if the A lead coefficient is negative, yeah, sorry, I wrote down COEFF. I didn't even tell you. I shorthand that. Coefficient. this one? Oh, geez, sorry. I just assumed everybody knows what I'm talking about. It's plus apostrophe VE. It means positive. Okay. Oops. Okay. I made a big assumption. Sorry. So this is coefficient is positive. If the leading coefficient is positive, right? The end behavior is quadrant 3, quadrant 1, right? Quadrant 3 to quadrant 1. Okay, hold on. If A, the lead coefficient, is negative, the end behavior is where? Quadrant, yeah, we're going to go the other way. Quadrant 2 to quadrant 4. Because we always do left to right. Left to right. Okay? Now, I know my colleague before, like, this is what he tells, this is what he tells his students. Actually, I'll wait until this one. Okay. My old co-worker. It's really funny. Hopefully that will help you remember. Okay, now let's take a look at the characteristics of the even degree. What's an even degree? It means degrees 2, 4, 6, so on, right? Degree. What do you notice about even degrees? Quadrants. Quadrant. What happens to the end behaviors?
The two ends go the same direction.
The two ends go in the same direction, either going up or going down. Okay. Yeah. So how do you describe that, Alwet? How would you describe that? Because, yeah, they go the same direction here. They go the same direction there. Quadrant 1 or 2.
If the leading coefficient is positive, if the leading coefficient is negative, they share both fourth quadrant and fourth quadrant.
Third and fourth quadrant. Yeah, excellent. Excellent explanation. Okay, excellent. So let's write that down. So if lead coefficient is plus, if, that means positive, the end behavior is quadrants 2 to quadrant 1, right? They're all up. Okay, and behavior. Now, if lead coefficient is negative, the end behavior is quadrant 3 to quadrant 4. Okay, now here's the thing. Do you guys know, this is like probably way before your time, or maybe it is some of you, it's your time. You know what disco is? Disco? Yeah? Okay, good. This is what my college. This is like way back when I was teaching in a different school. She was a dance student. I'm not a dancer, so I'll just pretend I know, but don't make fun of me. So this is the disco. This is the odd function.
Yeah.
Right?
Yes.
Right?
Yeah.
Positive, negative, right? That's the end behavior. Pretend it's a quadrant. 1, 2, 3, 4. Now what about the other one? Yay. Right? Positive is up. Look at my hand, arms up, down if it's negative. Okay, don't. Okay, some people might do that when they're graphing the functions, but That's how it is. Okay, now that we have that background, let's see if we can put it all together. That leads to example 1. See, we're already lesson 5. Lesson 5. Okay. Just by looking at that, okay, just by looking at this, tell me what you know. Tell me what you know about this polynomial function. Just one. What do you notice? Okay, opens upwards. Okay, so I'm gonna, yeah, so we know open upwards. How do you know that it opens upwards?
Because it's
Degree.
the highest.
Okay. Okay. So maybe one at a time. I know you want to jump right in and you get excited. Okay. So Awed says, "Hey, I noticed that this is a quartic, right? The highest exponent is degree 4, positive of 4. Okay. Okay. So what does that mean? So it's going to be the highest exponent is degree 4. Okay, let's write that down because this is important. We know it's degree 4. Yeah, 4th degree. Okay. So what? What else do you notice?
Your constant's 12.
The constant is 12. Okay, so you also said the you noticed, I'm just writing it down. Constant is 12. So what does that mean? Yeah, we already know that our graph will cross the y-axis at 12. That means y-intercept is 12. Good. What else do you know? Before we even graph this.
From quadrant 2 to quadrant 1 because of positive.
Positive what?
Positive exponent.
Okay, positive lead coefficient, right? So, positive lead coefficient. So, the graph will be quadrant 2 to 1. Quadrant 2 to quadrant 1. So this is a type of graph that kind of goes up. Arms both up. The ends go up. Yes? Okay. Well, those are the ones that we know of. Okay? But there's still other stuff that we still have to figure out. There's still a whole bunch of stuff that we have to figure out. So what do you think we should figure out to graph it? So far we have y-intercept. Yeah, we need to figure out the x-intercepts, right?
So we should assumption before that, right?
So,
Remember the theorem?
yeah. We're going to do the remainder theorem and factor theorem to figure out the x-intercepts. Very good. Okay, you've been studying, I can see. Okay, so let's do that. Okay, so how do we figure out, how do we factor this? So now we have to factor the polynomial. I'm writing this down, okay? This is what I'm really thinking. I'm putting it in words. So if you want to read this again, you know what to do. Now we have to factor the polynomial to determine the x-intercepts. Yes? Okay. And how do we suppose we do that? We need
The factor of 12.
the remainder theorem and factor theorem And we're also going to use, and we have to do the synthetic division. All the fun stuff that we did last week. All the great stuff we learned. So, okay, so how do we figure out one possible factor? So, how do we figure out one of the factors?
We should know the factors positive 12.
Yeah, we're gonna look for a factors of positive 12 because the factors of 12 will help us figure out the roots of the equation. Roots of the equation.
One is the factor.
Oh, you know for sure it's 1? Okay, so factors of, oops, you can't see that, of 12. And you've tried 1, okay? So let's use, I'm just gonna show it here. This is P of 1, or F of 1, doesn't matter. So P of 1 or F of 1. Actually use F of 1, because this is polynomial F of 1. And if we put 1, wherever there's an X, we're gonna go, P of 1 is gonna be 0. Is that correct? Because that's gonna give you 1 plus 3, so that's gonna, 1 plus 2 is 3, plus 12 is 15, positive 15, and then this one will give us a negative 15, so yeah, is 0. Okay, so we've already figured out using the remainder theorem and factor theorem. Since the remainder is 0, therefore x minus 1 is a factor. Oh, we found one factor. We found one factor. We're going to find all of them. Okay? So, how do we find our other ones? We're going to do the synthetic division. Okay, how do we do synthetic division? I got to be careful here. To do the synthetic division or long division, I have to make sure that I'm not missing a term, right? Okay, so this is 4, 3, 2, 1. This is 0. So that's going to be 1, 2, negative 7, negative 8, positive 12, or 12. So what are we going to put here? Divided by 1. Right? The a value, divided by the a value. So go ahead, if you know what you're doing, go ahead and perform the synthetic division. Remember, it's a factor. Your remainder should be 0 at the end. If you don't know how to do this, you bring down the 1. Multiply 1 times 1. This is the a value. That's going to be 2. Sorry. It's 1. It's 1. 1 times 1 is 1. Let's erase that one. 1 times 1 is 1. And then add them together. That makes it 3. 1. So 3 times 1 is 3. Add them together, negative 4. Negative 4 times 1 is negative 4. Add them together, that's negative 12. Negative 12 times 1, that's going to give us negative 12. It's going to be 0. So this is our remainder, 0. We know that because we already used the remainder theorem there. Okay, so what's the remaining polynomial? It's going to be x cubed plus 3x squared minus 4x minus 12. Okay, so we already know one factor. Now we're down to x cubed. We're going to factor it all the way down. Okay, so what's the other factor that we can use? Can we use 1 again? Okay, look at the factors of the negative 12. What are the factors of negative 12? It's 1, plus or minus 1, plus or minus 2. Okay. F of, can we use 1? Will that give us a 0 remainder? No. Can I use negative 1? No. Can I use 2?
Yeah, I guess.
Can I
12
use,
minus 6.
can I use 2? Would it work?
Yeah,
Okay.
2 was 2.
Positive 2. Let's try it. 2. If we put f of 2, that would give us 2 cubed plus 3 times 2 squared minus 4 times 2 minus 12. Okay, f of 2, that's going to give us 8. This is going to give us 12 times 3 is going to be 2.
It's 4 times
So, yes, plus 12. Okay, I'm already putting the 12 down. So that's going to be minus 8 and minus 12. Yes. So f of 2 is 0. Okay, f of 2 is 0. So what does that mean? Therefore, x minus 2 is a factor. Okay. They didn't give us enough room in here. So f of 2 is 0, so that means that x minus 2 is a factor. Okay, so if x minus 2 is a factor, I'm going to go back up here because I don't have enough room. I want to save this space for actually graphing. So we have to perform another synthetic division. Okay, so what's a synthetic division? What do I put in? It's going to be 1, 3, negative 4, and negative 12. Okay, good. So divide it by, what's the a value? A is 2. A is positive 2. So bring down the 1, right? The a value is positive 2. So bring down the 1. If you know how to do these synthetic division, why don't you go ahead? You know it, right? If you don't, you follow this. So you bring down the 1. 1 times 2 is 2, so you put 2 here. And then add them up, so 5. 5 times 2 is 10. Add them up, that's going to give us 6. 6 times 2 is 12. Add them up, 0. Okay, so the remaining polynomial would be what? X squared plus 5x plus 6. Okay, now we've gotten it down to just the quadratic. Okay, from here, it's easy to factor now, right? Okay, what's a factor of this one? 3 and 2, yeah? So it's going to be x plus 2, x plus 3. X plus 2 times x plus 3. So, what's a complete factor? Therefore, the factors are f of x is equals to x minus 1, that's the first one that we found. And then they have the x minus 2, and then x plus 2, and then the other one is times x plus 3. Okay, so we have 4 factors, and because we have 4 factors, we have 4 different roots. If we have 4 different roots, we have 4 x-intercepts. So, how does that go? Okay, let's put everything down. Ready?
Just a second, please.
Yeah, of course. Okay, good. Now if you're new here, you probably are just don't know what we're doing right now. I'll let you know where to get caught up. It's a lot of work. Okay, good. So far so good? Everybody wrote it down? So, what do we know so far? We know that the y-intercept is 12. Okay, so y-intercept is 12. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You know your graph is going to cross the y-axis at 12. So this is our 12. And what's our x-intercepts? What are the x-intercepts? The a values. It's 1. So it's going to cross there at 1. And it's going to be 2. 2. It's going to cross at 2. And then this one here. This one here is x plus 2. So that means it's the a is minus 2, right? Because it's x minus negative a. Minus a. So it's a negative 2. So negative 2. Right? And then this one will give us the minus 3. So minus 2, minus 3. Okay. So this is what that looks like. We have just 5 important points in here. Now, what should it look like? Remember, we said it's a degree 4. Remember, this is a degree 4. And it's a positive leading coefficient. So that means it should be in quadrant, the behavior should be in quadrants 2 to 1. So what does that look like? Okay, remember, where's the arms? Where do the arms go? Up in the air, both of them, right? Because, okay, so this is what it's going to be. And what we're trying to do is just trying to do the sketch, okay? We're going to try to do the sketch. I'm going to do it on a pencil because if I make a silly, weird error, then I can erase it. So here it goes. Should end up in quadrant 2 to 1. Any idea before I draw it up? It looks like a W. Yeah, it looks like a W. So it kind of goes like this. And it's going to go down a bit and bounce back up. Okay. And then fall back down. And then bounce and turns.
So it actually goes past the intercept?
Yeah, it goes through the intercepts.
So wouldn't the top of the W, like in the middle, be at 12 and not above 12 then?
No, this is the 12. This one here is whatever the negative 1 is.
No, but I mean when you're going like this, when you're going back down, wouldn't it cap out at 12? Instead of go above 12?
Oh, like it goes here? Now if it goes like that, that's kind of weird, right?
Okay.
Does it look like if it goes like this, and then it has to have like a sharp turn down to go back to the 3. So it's actually gonna go up and then back down to hit the y-intercept at 12. I think I know what you're talking about. Like it should go like this, right?
That's
Yeah. Okay.
And then go back down
Yeah.
from there, shouldn't it?
No, it will go up first and then go back down here. Now, the only thing that we're interested in, because this is a polynomial function, is that a polynomial function shouldn't have a sharp edges. So it has to be like very smooth, like hills and valleys, okay? Now, what are the key things that we're looking for? The key things that we're looking for here is that it is a smooth graph. Okay, it's not, I'm gonna show it to you. This is not what it looks like, okay? It's not gonna look like this. It's not gonna look like that, right? That's not a polynomial function. It has to be a very smooth up and down.
You have to be soft.
Huh?
Soft.
Yeah, like it's not sharp. Okay? What we're looking for here are the correct intercepts, x-intercept, y-intercept, and then the end behaviors. Oh, no, it's okay. Go ahead. What is it? Not sure.
This drawing, we are crossing, like, go over the 12.
Oh, no. Okay, so this one here, if this is -1, then that would be, okay, let's give it a try. Hold on. That's okay. Ask the question away. If you don't understand, okay, what's f of 1? Oh, sorry, -1. What's the value of a function when x is -1?
X plus 1.
No. -1. So that would be -1 to the 4 plus 2 times -1 cubed. Maybe this is gonna help. I'm thinking. Okay, hold on. Minus 7 times -1 squared minus 8 times -1 plus 12. Okay? Let's see that. So this is going to be -1 to the 4 is 1. That's going to be -1 cubed is -1 times 2 is -2. This one is going to be +1 times 7 is -7. 8 times -1 is +8 plus 12. Okay, good. Let's add them up. So this is going to give us 21. 21 minus 9. Okay, what's 21 minus 9?
No,
12. Oh, okay. I see. Now it's going to be... Okay. At -1, y is 12. So, if this is 12, it can't just go straight. So that means at negative, if we were to make table of values, remember how to make table of values? So x, y, right? If x is -1, positive 12. And then if x is 0, it's 12. Well, what happens if it's -0.5? What would happen if it's -0.5? What's the y? Let's figure it out. You know what? That's okay. That's the reason why we're having this conversation. So let's see what happens when it's at 0.5, -0.5. Okay, what is it? Okay, I'm just gonna do it the long way because I can't find my, oh, here's my calculator. I'm gonna calculate it, right? F of -0.5. I'm so glad somebody has the, what do you call that? Has the courage to ask why. I don't get it. Okay, here we go. -0.5 to the power 4, yes? Plus 2 times -0.5 cubed minus 7 times negative 0.5 squared minus 8 times negative 0.5 plus 12. Oh, okay. We gotta do all that stuff. Ready? Whoa, okay. Brackets, negative 0.5 to the power of 4 plus 2 times brackets, negative 0.5 to the power of 3 minus 7 times, or brackets, negative 0.5 to the power of, oops, brackets, 2 minus 8 times negative 0.5 plus 12. Oh, what the heck? Error. Okay, I might probably missed a bracket somewhere. Try it again. When there's an error, you gotta try again. Okay, so negative 0.5 to the bracket exponent 4 plus 2 brackets negative 0.5 to the exponent 3 minus 7 times negative 0.5 to the exponent 2. Oh, that's where I made a mistake. Brackets 2 exponent 2 minus 8 times negative 0.5 plus 12. Oh, please help me. 14. Okay. So that means if x is negative 0.5, what's the y? 14. So slightly higher. That's why there's a little bump there. So it says here, if this is a negative 0.5, yeah, what's the y? 14. So it's higher than 12. So it has a little bump right there. Does that clearly? Now we're not going to do table of values the way we did that, because you can see it takes forever to do that, right? We're just doing a sketch.
Yeah, but why on the graph when you have x minus 1 and x minus 2, you went over minus 3 and minus 2, you have to switch them positives? Like your last calculation there, where you have x minus 1 times x minus 2, x plus 2, x plus 3.
Oh, this one.
Yeah.
Okay.
You get your values
Yeah.
on the graph from that.
So these ones are the a value. So when you have x minus 1, your a value is 1.
Oh.
And then x minus 2, your a value is 2. Now if we go x plus 2, remember it's going to be, the factor is x minus a. So let's rewrite that. So it really looks like this, x minus negative 2.
Yeah.
So your a is negative 2. And then the last one, x plus 3, is, let's rewrite that as x minus negative 3. So a is equals to negative 3.
You use your last factor first,
Huh?
and then you use your last factor first always. Like what happens if I switch those factors up in different orders?
Oh, like these ones?
Yeah.
No, it's okay. Yeah, you can mix them around.
But then wouldn't I get a different
No.
value on the charts?
No, because this one, the 1 would still be over here. Okay. Let's say somebody wrote down f of x is equals to x plus 3, x plus 2, x minus 2, x minus 1.
Okay, so
The negative 3 will still be here.
those are the 4 intercepts that you're saying.
Yeah. Yeah.
And because we started with the lead coefficient, which is positive, it's going up.
Correct. Yeah.
What is the maximum value? Like,
So if there was, take out 2 of those, take out x plus 2 and x minus 2, there's only one way, is that right?
Yeah, then it won't be a quartic function.
Yeah.
Yeah. It would be something else. It would be just a quadratic function. Okay. Sorry, keep going.
I didn't know what's the point of the quadrant, quadrant 1 and 2.
Oh, what's a quadrant 1 and 2? That's the end behavior where it eventually ends, where these two arms are gonna go. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4.
Why you go right to left, not left, right?
Oh, this one here, left to right, left to right. So when we write the quadrant, the convention, yeah, it's 3, left from left to right. This one here, because this is an odd, okay, let's go back here, odd degree, so that's this one. I'll get to your question in a second. Let's just want to make sure that everyone's good. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Right? So we're going from this end goes from quadrant 3, and then this end goes to quadrant 1.
And
Right.
always,
So from
it's always in those, the quadrant 1, 2, 3, 4 is always like that?
oh, like this 1, 2, 3, 4.
Yes.
Oh yes, yeah, yeah. And then here, so we always start with the left side. So this left end behavior is quadrant 2, and then ends with and then this end goes to quadrant 4. Okay? And in this case, it's gonna be quadrant 2 to quadrant 1. Yeah.
The 0.5, why did you bring 0.5?
Oh, the reason why I brought the 0.5 is people were asking, why is there like a bump in here? Why didn't it just go straight that way? You know?
Oh, okay.
So I figured out this is 0.5, so that's the
Okay.
thing there.
I understand.
Okay, so far so good. And ask more questions if you have questions. Yeah. Oh, minimum and maximum. Good question. That's a good question. Are we interested in the local minimum and local maximum? The answer is no. We're not interested in the the highest here, the lowest it goes here. We're not interested in that. But what we're interested in is the shape, overall shape of the polynomial function, and the intercepts. Good question. Yeah. What else? Good stuff.
Like when I will go up from the -x. Okay? Yeah, -2.
-2.
When I'm going up to 12, why 12?
Oh, I just wrote down 12 there because people wanted to know why it bumps that way.
Yeah, that's what I'm asking about. The overthink this.
Yeah. The hill.
أيوة the hell. The hell. أيوة. Yeah, this is.
Yeah.
The hell. Like
Yeah.
when I will back down to x.
This one?
Yeah. Like I should be on the 12, exactly 12, right?
Yeah. When I fall down, then the graph has to fall in the 12. Yeah.
This is my
Yeah. Good. Very nice. Very nice questions. Okay. I'll give you a little bit of a break, and then we're going to talk about example 2, and we'll do example 3 and 4. Okay? So I'll give you about 5 minutes break.